the displacement of the body can be measured using three displacement, one along the x-axis, other along the y-axis, and other along the z-axis. Such motion is called a three-dimensional motion. If a motion takes place, motion of a body takes place in a plane, that motion is called a two-dimensional motion because two dimensions are required for that. Which dimensions? Y dimension and x dimension and y dimension. So vector y is equal to y into j cap. What is j cap? That is this. That means unit vector in the direction of y axis is called what is called j small j with a cap, j cap. Am I correct? I am talking about unit vectors only. Unit vector along the x-axis I capped, and the unit along the y-axis j capped, and the unit vector along the z-axis is called k capped. Unit vector k also we can say, or k capped we can say. K capped, C-A-P-E-D, capped. Cap means topi, what do you call cap. In Hindi it is called a topi, right? This is about the unit vectors. So unit vector is a vector having its magnitude unity and has the direction of the given vector. If I say vector A, what is the unit vector A? Unit vector A is A capped. When I talk about a vector B, what's the unit vector of that? That is equal to B capped. If I say a vector C, what is the unit vector? That is equal to C capped. How it is written, that also understood. These are called orthogonal unit vectors. Orthogonal unit vectors are unit vectors which are perpendicular to one another. Two vectors which are perpendicular to each other are called orthogonal vectors. If one vector makes an angle 90 degrees with the other, they are called orthogonal vectors. They are sometimes called as rectangular vectors also we can say. Right? So these are orthogonal vectors. Orthogonal vectors means vector I, vector j, and vector k. Why I, j, k are orthogonal? Because I and k angle is 90 degree. I and j angle is 90 degree. J and k angle is 90 degree. So that is why they are called orthogonal unit vectors. Which are orthogonal unit vectors? They are I capped, j capped, and k capped. Unit vector is also over. Then multiplication of a vector with a real number. Multiplication of a vector with a real number, right? Suppose there is a vector A. So suppose a vector A is multiplied by a real number lambda. Vector is this one, right? I am representing this is vector A. This vector is multiplied by a real number lambda. Then the magnitude of the vector increases, but direction remains the same, right? Lambda is a number that can be 10, that can be 15, that can be 20, whatever may be that, right? Then suppose this vector is what is called lambda vector A. Both are acting the same direction, right? Only the magnitude of vector A is changed by lambda times, but direction remains the same. Am I correct? So suppose this is multiplied with a negative number A, a negative integer, then this becomes like this, right? So negative. This I'm writing like this. Okay, this one. This is minus lambda A. That means in the opposite direction it is acting, right? So when a vector is multiplied by a number, a real number, then its magnitude is only changing, but the direction remains the same, right? If the multiplied the number which is multiplying is negative, then direction also in the opposite direction of the given vector. So this is about multiplication of a vector by a real number. So multiplying a vector by a real number, whether it is positive or negative, that determines in which the direction. If it is a positive number, then the vector A and the multiplied value lambda vector A both are the same direction. But if the number is negative, the direction becomes opposite, but the magnitude increases by lambda times, but in the opposite direction. So this is about vectors, unit vector, orthogonal vector, right? A capped, P capped, I capped, J capped, K capped, I, J, K capped. They are called orthogonal unit vectors. Orthogonal unit vectors are vectors acting perpendicular to one another. Along the x-axis, unit vector is what is called unit vector is I capped. When I write anytime, when I write vector y, I can write yj also. When I write vector x, I can write xi also because x-axis only have this can be possible. When I write vector z, that is equal to z into unit vector k. So this is the very important thing you have to remember, right? Okay. The total vector lambda is z axis. Vector z is equal to magnitude of vector z into unit vector in the direction of z axis. Unit vector in the direction of z axis, they have a unit vector k. So these are the things about this. It's addition of vectors. How two vectors can be added? Suppose there is a vector lying here like this. One vector is lying like this, and other vector is lying. This is vector A, this is vector A, and this is vector B. These two vectors are lying in a plane. We have to add vector A plus vector B. What we will do, right? When two vectors are lying in a plane and we wish to add these vectors, we have to take these two vectors as or adjust these two vectors as two adjacent sides of a triangle taken in order. We can make a triangle using these length as the sides, right? But remember, this side will be that means that side of the triangle, first side of the triangle will be parallel to this vector, and this will be parallel to the other vector. So I am taking this as the side of one side of a triangle. Okay, this is equal like this. This means with the same magnitude and the same. Okay, right? This vector where ends, the other vector is also taken, and also parallel. These two must be parallel, and also length must be same. So two vectors have to be added. Two vectors acting in a plane on a body. And what is the resultant of these two vectors? What is the total value of value of the vector acting on the body? Suppose two forces are acting on the body, on a body, right? And these two vectors are acting at different directions, one along this direction, other along this direction. We wish to calculate what is the total effect of the two forces acting on the body. One force is acting, one force is kept as one side of a triangle as shown in the figure, and other is kept as other side of the triangle shown here. But remember, when you adjust the sides, these lines must be parallel to the vectors lying in the plane, right? Okay, these two vectors are arranged. That means one vector ends, other vector starts, right? So these lines must be parallel to the vectors lying in the plane, right? Now you will see that the third side is taken in the reversed order. Reversed means this is in order and other is in the reversed order. We can write we can mark the arrow mark here also, right? So this is suppose this is vector A and this is vector B and this is resultant vector R is equal to vector A plus vector B. I can write. So this is what is called triangle law of addition of vectors. When two vectors are lying in a plane, or two vectors are acting on a body, and these two vectors are in the same plane, and these two vectors have to be added, we can arrange these two vectors as the adjacent sides of a triangle taken in order. Taken in order means one ends, other starts. That is called taken in order. Then the third side taken the reversed order. Third side taken the reversed order means in the reversed order. That will give you the resultant of these two vectors. This is what is called addition of two vectors, right? So this how we can. This is the first way how we can add these two vectors. And the next part, next is one more. Many ways we can add vectors, and one is the triangle of addition. Other is what you call the parallelogram law of addition, and the other one is polygon law of addition. Many ways vectors can be added. We study up to this much triangle of addition of vectors.